I'm Jess.
And I'm Kira.
And we are here today to tell you all about building data products one messy step at a time. We work for a technology learning platform called Pluralsight. And over the last couple of years, we've been focused on becoming a more data-driven product organization. And recently, we've become really focused also on building data products, specifically in the Boston office. So we're here today to share some insights we've gained as we sort of stumbled our way through that transformation. But we are by no means experts. We're just getting started and learning ourselves. So we want to come here and share what we've learned so far in the hopes that you all find it helpful.
So as just mentioned, we work for a company called Pluralsight. And Pluralsight is a technology learning platform with the explicit mission of democratizing tech skills. We know that's a pretty lofty mission, but we really want to give everyone everywhere access to technology learning. So in that vein, we offer expert-led online courses, interactive projects, adaptive skill assessments, and other tools to really help individuals and large companies keep up with the pace of technology.
So again, I'm Jess. I'm a UX designer, and I work on a piece of the product called Skill IQ. Skill IQ allows learners to quickly assess their proficiency in a technology. So when a learner comes into the platform, she can take advantage of an adaptive skill assessment and a variety of technologies like Angular, React, JavaScript. And by answering only about 20 questions, we can infer her proficiency in the entire breadth of that skill. We can identify gaps in her knowledge in that skill and then point her to content in her library to help her close those gaps.
And I'm Kira, and I work on a product called Role IQ. And Role IQ actually leverages the Skill IQ assessments that Jess's team builds to quantify an individual's technology proficiency, but in an overall role. So Skill IQ can quantify a learner's proficiency in React, and Role IQ can quantify that same learner's proficiency as a React web developer by measuring their proficiency in React and then 7 other skills. And what we're really trying to do with this is find the overlap in somebody's skill gaps across multiple skills so that we can point them to the right content so that they can learn and skill up in their role.
So before we get started, we want to just make sure that we all have a shared understanding of what it is we're talking about. So we have a couple definitions for you.
So what are we talking about when we're talking about data-driven products or data products? So when we say data-driven, what we mean is making design decisions based on behavioral data generated by our users. So we're really talking about products that rely on data gleaned from experimentation. So things like web analytics, A/B tests, surveys. We're also talking about products that use systems that learn from this behavioral data. So those are our machine learning models. What we're not talking about here is just a product that uses data. So a product that queries a database or uses a public API. And when we talk about machine learning, we're really referring to a system that can learn without being programmed. So machine learning is a subset of artificial intelligence. And the way that it works is that you have a pattern, which is also known as a model. You make a prediction, and then you update that model based on whether or not the prediction was right. And it's really all about pattern recognition. And Jess is actually going to walk you through a kind of simplified example of machine learning.
So something like this might look somewhat familiar to some of you here. Maybe this is an example from a picture book. So maybe you've looked at something similar that maybe it wasn't vegetables and fruits, maybe it was farm animals or shapes. But the way that this usually goes is you sit down with a small child and you point to things and you identify them. So you would point at this and you would say corn, and this is tomato, and this is a dragon fruit. And then later when you come back to this page, you again point to the objects, and then the child says corn and tomatoes, and you say, that's great, you got it. And then maybe you point to the avocado, and she says artichoke, and you say, no, honey, try again. So does that sound familiar to anybody? So congratulations, you are all machine learning engineers. You have all trained a machine learning model. It's a little simpler with humans. We kind of more quickly learn to identify things out in the wild. For a computer system, it takes like thousands of examples of corn labeled as corn before it's able to correctly identify that. But this just sort of gives you like a very basic idea of how machine learning and training machine learning model works. Okay, but that's machine learning, but why do we care? Well, we have some questions for you.
So how many of you have ever watched a recommended show or movie on Netflix? And
How many of you have taken a Lyft or an Uber, maybe even today?
and how many of you have ever found music that you loved or hated on Spotify?
And how many of you have ever gotten a fraudulent charge alert on your phone?
So it looks like that's most of us. And as you might know or have guessed, these are all examples of data products. So these are all systems that are learning from behavioral data generated by users like you. They're all using pattern recognition to either recommend things based on people like you, or in the case of a fraud alert, the system has been trained to notice outliers in your shopping patterns and then alert you when it notices them. And as you can see, machine learning is really all around us, and everyone is trying to use it to save customers like you time, money, and pain.
So what are we trying to do with machine learning at Pluralsight? Well, we'd like to introduce you to Alex. Alex is one of our personas. She is a new developer, what we call a newbie, and she's trying to learn Angular, both for her work and also to keep up with her peers. So as you can see, when Alex comes into our platform, she has a lot on her mind. She's thinking, what's my biggest skill gap in Angular? I don't have a lot of time, what should I be learning? Will this piece of content help me solve the thing that I'm stuck on at work? Is this content even relevant? Is it up to date and is it credible? And what are my peers learning that I should be learning too? So that she has a lot on her mind. She has a lot of needs that we need to meet. And she is only one slice of our customer base. So every learner who comes to Pluralsight has a different need, a different learning style. They're in a different environment. And they all come with different backgrounds, different amounts of experience and related knowledge. And at Pluralsight, we've become really good at creating high quality content, but where we sometimes struggle is connecting that content, getting the right content to the right user at the right time. So what we want to do with machine learning is we want to create a personalized experience that will meet each learner where she is in her learning journey so that we can help her skill up most effectively. But to do that at scale, we have to leverage machine learning. There's no other way.
So how do we start doing that? So at Pluralsight, we're really focused on human-centered design, and that's how we've been building products for years. And while we're focused on becoming more data-driven as a company, we still need human-centered design at the heart of it all to understand users' needs, because machine learning alone isn't going to do that for us. So to that end, we really love this quote by Jess Robash from Google, who said, "If you aren't aligned with a human need, you're just going to build a very powerful system to address a very small or perhaps non-existent problem." So we at Pluralsight use a human-centered design framework called Directed Discovery. And Directed Discovery was actually created by our Chief Experience Officer, Nate Walkingshaw. And this process really spans research, development, and the product launch. So we want to share how we've kind of taken this human-centered design framework and then gradually layered in a more data-driven approach. But first, here's an overview at Directed Discovery.
So Directed Discovery has kind of three main phases, but the place where we always like to start is with personas. So you probably already know personas are fictional representations of various kind of segments of your users. You met one of ours earlier, Alex, the newbie. And what we like to do with them is just sort of use them as a tool to make sure that we're all aligned. Everyone on our team and any teams that we're collaborating with are aligned on who it is we're building whatever feature for and who it is we're not. And then the next kind of real phase of Directed Discovery is the VOC, or the voice of the customer. And here we're discovering. We're trying to understand the needs of our users. We want to know what are they trying to accomplish both in the platform and outside of that. Where are their pain points and what kind of opportunities are being created by those. So we're conducting interviews, doing contextual inquiry. We're looking at the customer support Slack channel, that sort of thing.
And the second phase of Directed Discovery is what we call the customer preference test. And this is really where we do the bulk of our user testing. So after we've synthesized everything we've learned from our voice of customer interviews, and we've done narratives, and we've created wireframes, we really generate one or two possible design solutions. And these are really in the form of high-fidelity clickable prototypes. We put those prototypes in front of our users, either during video calls or in-person sessions, and at this point, we're really vetting our ideas. We spend a lot of time in this phase because we're really trying to understand if we've solved the problem, and then once we've confirmed that, whether or not the design itself makes sense.
And then the last phase is the customer confirmation test, or the CCT. And here we have developed what it was that we were testing, and we are deploying it to users in stages, so alpha, beta, and then general release. And we're trying to, at this point, really understand, we're measuring the effectiveness of the experience. Generally, we use a tool called WebEngage to pop up in-app surveys. But we're also looking at usage data here to see, if we are releasing something, but adoption is really low, and we need to kind of dig into that and understand, well, can they not find the thing? Do they not understand it? So we might say stop the presses and sort of take a minute to understand what's going on before we can get to a point where we're comfortable releasing to the general public.
So that was sort of a look at how human-centered design has traditionally been done at Pluralsight, and as you can see, it was mostly a qualitative process. Now, when we're talking about building data products, we don't want to disregard this directed discovery framework, but just layer in a more data-driven approach. And this is going to enable us to have a more well-rounded understanding of the problem and get ahead of some of the issues that can arise when integrating more data or machine learning models into our product. So how do personas differ with this data-driven approach? The way we approach them is pretty similar, whether you have more data or not. But we use a lot of more advanced web analytics to really get a better sense of user needs and also their learning styles and habits. So whereas in the past, we had a pretty stock understanding of how personas like newbie or expert, how they consume content on their platform, analytics really give us a better idea into their behavior and how a newbie consumes content on the platform versus somebody who's more advanced. And what the data has really shown is a clear differentiation between what we call a newbie deep diver. So somebody comes to Pluralsight really looking to consume all of the content from beginner to intermediate, end to end in a skill to learn it from scratch, versus somebody who's a more expert browser who comes and uses our search engine to find the little bits of content that they need to skill up in their role.
So in the data-driven version of VOC, the voice of the customer phase, we're still interviewing customers to understand their needs, but we're also reviewing analytics to see if there are other opportunities, and also as a way to sort of prove out need. If people are dropping off in some part of the flow, then clearly we need to kind of dig into that. We're also, in addition to the interviews, running experiments when we can, as just kind of another way of validating hypotheses. So, for example, we had this idea that some types of content might be considered more engaging to users than others, and we wanted to learn a little more about that. So we came up with this idea of a lightweight component that we wanted to put on the home page that would just sort of cycle through different types of content, and we were just interested in finding out what people would click on. And the idea there was if there was a type of content in particular that people were really engaging with the most, then we should probably be surfacing that to users right away when they come into the platform. And then the last point is really about how you kind of have to rethink the VOC phase when you're building for machine learning. So you're no longer just trying to understand the needs of users, you're also trying to understand the impact of the model on the users, and specifically, what happens when the model gets it wrong. So this is an example. These are recommendations that we give to users once they finish the assessment. These are content recommendations based on how they did. And when we were first releasing this, we knew that the model was a little shaky and that there were going to be times when a recommendation came back that just didn't make any sense. And so in the VOC phase, we had to spend extra time kind of trying to understand what was that impact going to be to the user. If we show them one bad recommendation, is it going to invalidate all the other recommendations in the minds of the users? So we also spent some time trying to come up with, understand ways that we might mitigate that negative impact. So what we finally came up with was that when we released this, we sort of couched it as being in beta, and we found that sort of softened users' approach to, that users' understanding of, this is still kind of not a fully baked experience. There might be some little hiccups. We get it. The other thing we did is that we gave the opportunity to users to let us know that the recommendations were bad. And we did this for a couple of reasons that we'll get into. But by giving users the ability to kind of like act on the bad recommendation, that helped kind of mitigate any kind of negative feelings they might feel about getting this weird out of left field recommendation. And then in the data-driven version of the CPT phase, we're still designing, testing, and iterating. We're still putting prototypes in front of users to try and understand if things if we're solving the problem. But in addition, we're trying to collect data in other ways. For example, running experiments. So those recommendations that I just showed you, we were trying to understand if showing them in one format or another would result in kind of better engagement with them. And what we ended up doing is running an A/B test to discover if that was the case, and we did actually get some really clear, what we felt was really clear data that there was one format that was going to work better, was going to result in better engagement than the other. So it's just another way to collect data where we're having trouble pulling that out of the traditional prototyping experience. And then the last two bullets here, test your model and design for feedback. Those again are about how you kind of need to adapt this phase when you're building for machine learning. So when we're talking about testing the model, what we're saying here is that it's no longer going to work to put mock data in an envision prototype and see how that works. You really need to get the actual data in the hands of the users, both to see how the users want to interact with the data, and then to see if the output is working for the users. The other thing you want to do is you want to work with data scientists to test various models against each other to determine what model is going to give you the output that's right for what you're trying to do. So this is a data prototype created by one of our data scientists, where we were trying to understand if using one type of tag over another had a better impact on the recommendations that the algorithm was producing. And then that last point about designing for feedback, we just want to spend a couple minutes here because first off, when we say feedback in this context, we're not talking about the usual feedback you're talking about with interaction design, where you click a button and then you see a loading spinner and that's how your visual cue that something is happening. For machine learning, remember you've got this prediction, and then you need to let the model know whether or not the prediction was right. And so the model needs to be able to learn. So if you're not collecting either implicit or explicit feedback and then feeding that back into the model, you don't have machine learning.
So when we're talking about explicit feedback, we mean something more like this. So thumbs up, thumbs down is a form of explicit feedback where the user knows that they're giving feedback. They know that they're letting the system know whether a recommendation was good or bad, or whether they liked something. And they also know that this feedback is going to have a discrete impact on what they see in the future. On the other hand, this is actually an example of implicit feedback, where the user doesn't necessarily realize that they're giving feedback, but the act of clicking on one thing over the other is behavioral data that we're feeding back into our model. So in this case, we're actually asking the user to self-select their current perceived role level as a Vue web developer to collect a set of data points that influenced our preliminary level setting model for role IQ. And this self-assessed level helped us pinpoint the most accurate thresholds for the skills as they related to that role, rather than just using the existing skill IQ buckets that we had indiscriminately. The other thing to think about when you're designing for feedback is not just whether you need, explicit or implicit interactions, but also, the level of granularity around your feedback. So in the case of content recommendations, we actually moved away from the kind of simplistic thumbs up, thumbs down, because we found it was too vague to be helpful for our users. And we settled on something that had more explicit reasons for, why the content was not relevant to them. And that was able to, generate much better, more robust feedback for our model. So when you're working on a machine learning product, you do need to think about the design a little bit differently. You need to think about the flow a little bit differently. And you need to be thinking about how to build in different interactions that are going to help your model and your feature improve over time. So in the last phase, the customer confirmation phase, when you add in data, what you're really trying to do in this phase is validate your hypothesis. You've designed for feedback, you have this feedback, and now you need a way to use that feedback to influence and iterate on your newly launched product. So you're either going to validate your original hypothesis and continue building from that, or you're going to generate a new hypothesis based on the behavioral data that you've acquired. You're also going to test your model and its output in this phase. Once your product is live, you really have stark data around whether or not the model was a success or a failure, and that's really going to shape your next steps in the next evolution of your model. You're also going to want to design for improved feedback. So what you need to do is look at the remaining needs of your users, because there always are remaining needs, and then figure out what is needed to actually push the model forward. So in the case of Rule IQ, we actually evolved our level setting model by incorporating a third data set, which was actually collected via manager feedback. So we conducted interviews with managers and administrators involved in our Rule IQ beta, and their recommended skill thresholds we used to adjust the thresholds for each skill within the context of a role. So we started with a V1 of our thresholds based off of that one set of implicit data points that we showed earlier, those self-assessed levels. And then we went back to yet another data set to inform a model and generate, V2 of our thresholds. And as you can see, there's a meaningful result from the outset. We always had levels, but we just wanted to continue to refine the experience to make it more accurate and more precise.
So gathering, data through experiments and qualitative surveys, it's just like qualitative. It's another way of discovering new possibilities and finding new opportunities. It's just another piece of the story. So we hope that we've been clear that we're not saying drop all the qualitative work you're doing and rely solely on A/B tests and experiments and machine learning algorithms, because that's not what we're saying. We think data can tell you what's happening, but we really believe that you need to still be talking to your users to understand the why.
And so we want to leave you with some tips on getting started. We know not everyone, will leave and go back to a team of data scientists and machine learning engineers, but given how prevalent data products are becoming, it's good to start thinking about these things because maybe someday you will have a team like that. And no matter where you kind of are in your process, we wanted to give you some little insights that you can go back and take to your day-to-day work and become more data-driven. So our first tip is really to collaborate as much as possible. So getting everyone in the room early on is going to make sure that everyone has a shared understanding of the problem. And when you have all these different stakeholders, they're going to start asking different questions from their own perspective. And they're going to start bringing up, things that you haven't thought of and all this data that's going to help strengthen the model. This also prevents you from, working in a silo or designing with fake data that's going to lead you down the wrong design path really quickly. A data scientist in particular can, help you figure out what data you need, what data you have, and then also what experiments you need to run to give you clarity on how to move forward. Our next step is to get experimental. So doing quick and dirty experiments is a really great way to start testing some of your long-held assumptions and your kind of base level hypotheses before your team starts spending precious time, designing and developing your experiences. Experiments are also a great way to start uncovering whether you have all of the data and the pieces that you need for your production level machine learning models.
And when we're talking about experiments, running experiments doesn't mean that you need to have a complicated framework set up to run multivariate tests. In some cases, all you need is email. So I mentioned earlier that we were trying to understand what the better format was to show to users for those content recommendations. So what we were trying to understand is whether we showed those content recommendations with the skill gaps that they related to, if that would increase the validity of the recommendations in the mind of the users and therefore result in more engagement. So what we did is we selected a group of users and we generated content recommendations for those users. And these were real content recommendations based on an assessment they had recently taken. And then we just emailed it to the users. And half the users got an email that said, hey, you recently took JavaScript, and based on your results, we recommend you watch these courses. And then the other half of the group got an email that said, hey, you recently took JavaScript, and based on your results, we believe that your area for greatest improvement is X topic, and here's some content to watch. And what we found was the second group, the group that included the skill gaps in it, actually performed 57% better. People clicked into it 50% more than the other group that didn't include the skill gaps. So it took less than a month to come up with this, to run it, to kind of like understand the data. It took 0 engineering time, and it kind of quickly and easily pointed us in a direction that we felt confident moving forward in. And then the last tip we want to leave you with is, take stock of what you have and see if you can work with what you have. So for data, that means sort of evaluating whatever data you can get your hands on to try and understand if that's relevant to what you're trying to do, and also see where your skill gaps are, and that can be useful and to know as you're building your product out. You can kind of try to build in ways to collect that data and fill in those gaps. It's also good to remember that sometimes you do need new data, but sometimes you can actually, if you're looking at data just from different perspectives, and a data scientist is really helpful here, you can actually figure out that the data you have is enough to get you started. But this goes for tools as well. So I mentioned earlier that in the CCT phase, we pop up in-app surveys using a tool called WebEngage. So recently we had a need we wanted to get users who had just finished an assessment, and we wanted to push them into another assessment in a related skill. And one of the product managers in our organization had the idea to use WebEngage to do that. And we weren't popping up surveys asking them, hey, did you like that? We were saying, you just took React, would you be willing to take Redux? And it worked really well. And the other thing it did for us is that we had, for a while, had this idea, this hypothesis that when a user finishes one assessment, they would be interested in seeing what other skill assessments we have that are related to that skill. So that's definitely something that we feel more confident is something we need to dig in on as we go through the next iteration of this results page. And finally, before we leave you, we just have a few things to keep in mind as you're kind of making your way in this brave new world of data-driven design and data products.
So one of the first things you should do when you're thinking about building a data product is kind of a base level cost-benefit analysis. I know we've been talking a lot about experiments on experiments on experiments, but if you can actually learn from one of our failures, we were trying to figure out when the best time to surface retakes on an assessment so that somebody could reassess their skill level. And we had this idealized experiment where we spent 1 to 2 weeks planning the experiment, 1 to 2 weeks building with a developer, 1 to 2 weeks carrying out the experiment, and then another 1 to 2 weeks actually culling through the data trying to find insights. And at the end of it all, we realized that we could have just built a skateboard of our feature in that same amount of time, and we would have gotten actual user data that probably would have given us better insights than what we had gotten through the experiment. So sometimes it is, a basic question of whether you should, carry out a full-fledged experiment or just build the thing. The other thing to think about is whether or not you even need machine learning, and whether you're over-engineering a solution. One of my favorite examples of this is actually through Gmail. So if you're like me, you often start writing an email and you say the words, I attached, you hit send, and then a handy little pop-up comes up that says, did you mean to actually attach a document? And of course you do. You go back, you attach the document, and it saves you, embarrassment and time. You might think that, Google, with all of its resources, made this fancy machine learning model with natural language processing, but it's not. It's literally, kind of basic logic that's literally just trawling through your email looking for the words attachment or attached. And they, did a cost-benefit analysis to say, we don't need anything fancy because most of the time our users are just using those words, and we can add real user value without getting too complicated. The other thing to keep in mind when you're building a data product is how do you strike the right balance? Often when you add more intelligence into your products or your platform, there's a very fine line between personalization and weird or creepiness. Another Gmail example. I don't know if you've noticed this, but Gmail started recently writing my emails. Not really sure how I feel about it because it makes me think that I only write 1 of 2 emails. But one of the things that can mitigate that weirdness is the ability to turn it off. I can go to my settings, I can turn off predictive text. It's a very simple way that gives me more control over my experience. Another thing that they could have done to sort of mitigate that is, having a little modal or a pop-up that kind of primed you and warned you that this feature was coming, so you weren't waylaid by it when you started writing an email. The other thing to think about is, this balance between fluidity and timing. One of my friends, she loves the TV show Friends, like all of us, and she likes to watch it every morning when she gets ready for work. So Monday through Friday, like clockwork, 6:30 in the morning, she opens up her laptop, goes to Netflix, and watches Friends. She just has it playing in the background. You would think that Netflix by now would have learned her habits, and when she opens up Netflix at 6:30 on Monday, she sees Friends right there. But it's not the case. She has to search for it every single time. And that's because Netflix has prioritized reshuffling and recommending content based on what she last consumed, rather than that timing, that fluidity, or that time of day. They prioritize fluidity. And that's something that we're always kind of thinking about at Pluralsight. Do our users want to, come to this dynamic homepage every time they log on that's different based on the content they've consumed? Or do they want to see something, that has maybe a carousel of all the content that they had previously started but not finished, so that they can jump right back into where they were learning? And really the thing here to think about is always, balancing the user's intent and thinking about what they want to do when they come to your product. So if there's anything we can leave with as you leave here today, it's this idea of investing time and becoming more data literate. We know there's tons of great resources out there for product designers and product managers to kind of learn the key concepts around building machine learning products. And having that strong baseline knowledge is so important for communicating with your team, for evangelizing in your company, and then knowing your options when you're actually building out your data product.
And that's pretty much it. I think everybody gets access to our slides at the end of this. So we've actually included a slide at the end of our presentation that has a bunch of resources listed that we've found really helpful about building data into your product and also machine learning. So we hope that you also find those helpful. So thank you. And does anybody have any questions?
First, want to say thanks for giving this presentation. You guys might think that you're just starting out and don't know everything yet, but this was huge for a lot of us to learn, so thank you. One very specific question. You sort of listed the groups of people you want to get involved early and often. You had a differentiator between an engineer and an ML engineer. What makes an ML engineer specifically? What would you be looking for? What skill set?
So most of the time, a software developer is going to actually be building your product. What a machine learning engineer is, they're really a data scientist that's transforming all of the models that data scientists are coming up with, and they're making it production level code. So they're probably not building your UI. They're probably using other tools and technologies to actually build out, those machine learning models. It's a slightly different skill set. I don't have specifics on the technologies that they use, but there's definitely a differentiation in our organization versus somebody who's, a full stack developer who writes in React and Python versus somebody who's probably writing in Python to create that machine learning model and translating what the data scientist is doing so that it actually performs in your product.
A couple over here.
I'm interested in kind of the relationship with the data scientists on the team. Can you speak a little bit to kind of the process for the data science work, in line with the engineers' work or agile process, and kind of how you got to a place where that works?
Well, our organization is sort of set up where, so the teams are cross-functional, so on every team, we all own different parts of the product, and there's always a UX designer, a product manager, and then several engineers that you're working with. And then there's a whole group of data scientists who are sort of, they're kind of jumping in and out of products or projects as needed. So we kind of when we know that we're going to be working on something where we need, some data insight, we'll sort of just go to them and, pull one of them in. And we bring them into the process really early, as Kira mentioned, when we're first kind of talking about like what it is we think we're trying to understand. We even involve them in the VOCs and the CPTs so they can see, so they both like build empathy, get a better understanding of the problem is that we're trying to solve, and then they can kind of come up with, they're like, oh, I see what you need here, and I have this idea of something that might work. So that's generally how we've worked to date.
If I can just add to that, we do have them in our narrative sessions. So when we're talking about, we believe that this is really the problem space that we're trying to tackle first, we bring in a data scientist at that level to really ideate with us, because otherwise you kind of start designing and then you're going to have to revise your designs based on what's possible from a data science perspective. And they think about things like 180 degrees differently than you do. And they're willing to usually like work around the designs that you want. So they're not super opinionated about the data most of the time. And if you can bring them in early to that narrative session, they're gonna bring up good ideas and data points that they would need based off of the ideas that are coming out of that session that you can actually draw from.
Right, which again then helps you think about like how it is you're going to work those mechanisms in to collect the data you need to then feed the model or do whatever you need to do with the data. Was there somebody? There are a few more people.
Hello. I was really interested in the way that you had so many tags, and I was wondering how you first started to approach how you defined what the tags were, and potentially like if you had too many tags, like from the user experience, how is that going to work? How did you balance those two?
So that was actually not a prototype that I was specifically involved in. It was one of our coworkers working with a data scientist on that project. But they were kind of drawing from tags that already exist in our experience, ways that we're already tagging our content. And there are a lot of them, and it can be a little chaotic at times. So that's something that we're actually trying to revisit now, is sort of a better sense of, even should we allow users to select from all these tags, because at a certain point, if you select 40 things, then it's no longer super useful to us. So we found, and that is something that we discovered once we kind of released that experience. We're like, I guess we need to kind of go back in there and tweak it a little so that we can make it a more useful, way of gaining information.
And the tags are kind of passed on to us. So the tags are around each of the courses in our content library. And those are really built in when we contract a subject matter expert to create a course. They, along with an editor, come up with those tags that they'd use to tag the course. And we don't have a great system for it right now. So like an intro to programming course could be tagged with like JavaScript, Angular, React, and that's really not accurate. It should have a different type of tag, and it's showing up in different searches where maybe it should be, maybe it shouldn't be, and we actually have to run more tests to figure out, how to tag things accurately. I'd say generally more tags is better, but it's also that like balance between accuracy.
Right, and I think and also we're trying to kind of create a hierarchy amongst those tags, which tags kind of take precedent. There's one here, there's another woman over here.
Hi. So when you're designing with respect to data as well, right? Are you considering designing for outliers as well, or do you just consider like the vast majority of data that you get in when you're designing prototypes?
So the question was, are we designing for outliers in the data?
Yeah.
Or, we're sort of we're definitely like taking them into consideration and then sort of like weighing again it's the cost benefit analysis of what's the right amount to show people. For example, in the analytics that we show when somebody takes an assessment, we're also showing that their kind of result to their manager, but we we don't show, when we give them kind of like the overall view of how their team is doing, if there's like a score that's kind of way over here, that's going to kind of throw everything off, we don't show that, and we specifically say that we're only showing like the 20th and the 80th percent. So that's sort of how we moderate what we're showing people, and we just try to be sure that we're then explaining, like, this is what you're seeing. So.
I'm curious if you guys have ever ran into a case where maybe there's a conflict between the data science side and the user experience side. For example, where you need to ask the user for information because it would feed the models, it would be really helpful for your product, but from a user experience standpoint, you can't find a good way to add it to the experience, or your designers feel like it would conflict with the product from the user standpoint.
So I can take that one. So one of the things that I showed earlier, that implicit data collection, that was integral to setting precise thresholds. So when you take all these assessments, we can give you all these skill scores, but then what's your aggregate role level? So that modal that we pop up was really hard to figure out how to build it. That was one thing that data science insisted that they needed. We couldn't just use, the existing data from our users and come up with an average. They really needed another data set to sort of like move the needle one way or the other. And we don't get great feedback on that modal. A lot of people say, what does this mean? And the burden, fell on me in that case to really try and explain, why the heck we need that information, and then try to surface it in a way that feels more integral to the product. So it is definitely a tricky balance. I'd say most of the time, the way to get ahead of that is just to have a data scientist earlier in the process, as early as possible, because if I had come up with a more idealized version of that flow and hadn't talked to the data scientist and just been like, well, it's all well and good, the data scientists will do their magic and like figure out from this data, we would have had a broken experience where like the role level would have said pending for a million years. So it was really important to talk to them and try and figure out a way to, not break the user experience. Maybe it's a little bit more of a burden on the user, but not too much, and trying to balance that.
Hi, so I also work on a recommendations product, so I totally feel you guys when it's really hard to do qualitative on recommendations because when they're good, customers don't necessarily notice them. So I'm just wondering, especially paired with quantitative, if you guys have ever seen a real conflict between the feedback you're getting, like if the data is telling you one thing but qualitative is saying something totally different. If you guys have run into that, and like, does one win in the end, or what do you do in that situation?
We've had an experience where we've definitely had experiences where there have been, it's been kind of inconclusive, where we redesigned a piece of the assessment flow, and it had been kind of a bad experience for a while, and we knew that we needed to fix it. And so we were finally able to prioritize it, and we took what had been like 4 or 5 clicks to get into the assessment. We reduced it down to basically 1. We talked to users to understand what they needed to know before they were jumping into an assessment, all this stuff. And so we felt really good about the thing that we ended up creating, and we put it out there. And then when we looked at the analytics, the kind of engagement rate didn't really change that much. So that's an example of where the quantitative data isn't going to tell you everything, because I think without a doubt it's a better experience, but we still need to go back and understand. Clearly it still needs improvement. So we need to understand more. We need to understand why, like what is the next thing that we can do to kind of move this along. So we were kind of surprised to see like, oh, we thought we were like knocked it out of the park, but then the data didn't kind of like confirm that. So that's kind of a place where it was more there I feel like we're kind of relying a little bit more, it's a combination of quantitative, qualitative, and gut feel. So we still feel like it's a better experience and it was worth actually releasing it. But we're still then now working on kind of digging into, in a more qualitative way, understanding, why it didn't, succeed as well as we expected. So we have time for one more question. There's a woman over here in a blue shirt who has had her hand up a lot.
Sorry.
Oh,
Who else has it? Okay. How have you been thinking about understanding user intent when coming onto your homepage?
I'm sorry, say that again?
So you kind of hinted at the end with the Netflix example, with how you measure or understand user intent. Like, how have you been tackling that problem?
That's a good one that we actually specifically don't work on that piece of the product. So, but I know that what Kira alluded to with this desire to, what we're trying to do is make something that is more personalized, but at the same time keep in mind, what is the user's intent, and so keeping that timing component in mind as well. So there are, I think we have to do a lot more digging into, understanding what people's behaviors are when they come into the platform at different times, and then kind of build to that. So that's kind of as far as I know that we've gotten. I don't know if you have any other insights.
The other thing that we're doing, so right now it isn't dynamic. It doesn't change that much. It really is a bunch of different carousels based on recommendations on what you last consumed or what you, like courses that you started but didn't finish. And the first step that we're doing is, analyzing which parts of that homepage get the most engagement. And we're holding those things constant and then swapping in different components that are more dynamic to see how those perform against the things that currently exist and are doing pretty well. So that's sort of the first phase with understanding the user's intent and holding a couple variables constant and then changing a few different things to, it's kind of, that's just in like the user testing flow and trying to figure out, does the dynamic component make sense here?
And that was an intentional move on the homepage team's part, was to make all of these pieces components so that they could move them around and pull one out and put another one in. So that was sort of like the kind of very starting point that they, where they started, so that they could start to understand better, what would be the right experience for the users. I think that is it. Thank you so much.